Hey guys, and welcome back. Today we are going to be talking about the formation of ions. Now, up until this point, when we've talked about the atom, we have talked about neutral atoms. So our 8-man, where the atomic number is equal to the number of protons and it is also equal to the number of electrons. Well, today that is going to change because we are going to learn how ions form and how it can affect the charge of the atom of the element. So let's go ahead and jump right in. So really quick review. If we don't have this by now, we got to get it before we get started with ions, because if we don't have the foundation of atomic structure and know the charges of the particle, this next part is going to be really difficult. So remember that our atom has our nucleus, where most of the mass is, that has our positive protons and our neutrally charged neutrons, right? So our atomic mass is our protons plus our neutrons. The protons are positively charged. The electrons exist in the electron cloud. They have so little mass we don't consider them to have mass, and they are negatively charged. Atoms are composed of all three, but when we talk about ions, we're only concerned with the electrons and the protons, okay? So we're not going to have to worry about the neutrons because it's the protons and the electrons that will determine the charge of the atom, right? Because again, up till now, let's take, again, like carbon for example. In a neutral carbon atom, it has 6 protons, which are positive, and 6 electrons, which are negative, and because 6 minus and 6 plus equal each other out, the entire atom is neutral. But when we talk about ions, the atom won't necessarily be neutral any longer. So that's it. That's exactly what I just explained. Sorry, I kind of jumped the gun there. But a neutral atom just means the charges cancel out. So you have the same amount of protons in the nucleus that you have of electrons that are existing in the electron cloud. Okay, so the atom is neutral. So what is an ion? An ion is an atom with extra electrons or missing electrons. Okay, so it's either the atom is gaining electrons or it's giving electrons away. Okay, we'll talk about what type of elements do which. Okay, so the example here, so we start with a neutral atom with 4 protons and 4 electrons. They cancel each other out. But in this atom, it's still the same element because it still has 4 protons. So remember, the protons are still going to determine the identity of the element. So we still have 4 protons here, so it'll still be the same element. But this particular atom has gained 2 electrons here. So it's gained 2 electrons, and because there's now 2 more electrons than there are protons, and because electrons are negative, the overall charge of this atom is now -2 instead of 0. So remember, protons are in the center and electrons are on the outside. Only the electrons can be added or taken away here. So we're only going to be dealing with electrons either increasing or decreasing. Remember, the protons have to remain the same because the protons determine the identity of the element. So we're not worried about the protons changing. All that's changing here are the electrons. They're either going to be added or taken away from the atom. So again, same thing that we saw in that picture. I've already kind of explained it. We have this atom with 4 protons in the nucleus and 4 electrons in the electron cloud. 4 plus and 4 minus equal each other out, so this creates a neutral atom. So to find the net charge of an atom, you just add the number of positive charges and the number of negative charges, and you want to make sure you keep your signs the same, so whether it's a positive or a negative. So this example here, in this image, we've got a positive of 4, so 4 plus, and then we've got 3 negative electrons, so 4 protons and 3 electrons. So plus 4 plus -3 will give us an overall charge of +1. So the charge on this particular element or this atom of the element would be +1. Okay, so that ion would be positively charged. Okay. All right, so I'm going to throw some examples up here, and if you guys could, just go ahead and pause and you can write the examples in your notebook and try to figure out the charges of these examples, okay? So since it's a video, you guys will be able to pause and check yourself, but I'm going to go ahead and move forward through the examples, okay? So here we have 4 positive protons, 2 negative electrons. Oh, sorry, I didn't even have the answer. So here, +4 plus -2 would be an overall charge of +2. So your answer should be a charge of +2. Example 2, go ahead and pause and try to figure out what the charge is. So we have, again, 4 positive protons and 1, 2, 3, 4, 5 negative electrons. So +4 plus -5 is going to give us an overall charge of a -1. So this atom would have a charge of -1. And finally, we have a nucleus with 4 protons still. Again, we're not changing the protons, so 4 plus, and then 1, 2, 3, 4, 5, 6 negative electrons. So +4 plus -6 is going to give us an overall charge of -2. So if we haven't seen through doing those few examples, when we add electrons, the atom will gain negative charges and become negative. Now, this is how it can get a little bit tricky when we're trying to determine charges. A lot of times when we think of adding something, we think of a number going up, right? So positively. But because the electrons are negatively charged, if we add more electrons, the atom will become more negative, okay? So adding electrons, the atom will become more negative. When we remove the electrons, the atom will lose those negative charges and become more positive, because if you're taking those electrons away, you're going to have the positive protons in the nucleus outweighing the electrons in the electron cloud, and so your overall charge will be positive. So adding electrons becomes negative, removing electrons becomes positive. So atoms without a charge are just called atoms. We call them a neutral atom, and that is what we've been talking about up until today. So when we've done 8-man and all those Bohr models, we have been doing them with neutral atoms, okay? If they have a positive or a negative charge, they are called ions, okay? So if you had, let's say we have an atom of sodium, right? If we just say sodium atom, we are assuming it's a neutral atom of sodium. However, if we say sodium ion, we know it's going to have a charge to it. So that's just the jargon that we're going to use to help us differentiate between a neutral atom and an ion. Again, the number of protons always stays the same. The only thing changing are the electrons. So they're either being added or taken away. Okay? Now, if an ion loses 1 or more electrons, it becomes positive, and it's known as a cation. Okay, so a positive ion is known as a cation. And if an ion gains 1 or more electrons, it becomes negative, and it's called an anion. Okay, so like here, for example, we've got sodium. A neutral atom of sodium has 11 protons and 11 electrons. However, if it loses an electron, remember electrons are negatively charged, so those positive protons in the nucleus, those charges are going to outweigh the negative charges now, and so sodium will have a charge of +1. So we would call this a sodium cation because it is positive. Here with chlorine, chlorine's a halogen. It has 17 protons, 17 electrons in a neutral atom of chlorine. However, if chlorine decides to gain an electron, so it adds an electron to its outer energy shell, then it's going to become negatively charged, and this would be a chlorine anion. So the charge on this would be -1, and we would call that a chlorine anion. So again, if it's neutral, we would just say sodium atom, chlorine atom. Here, this would be a sodium cation or a chlorine anion. So again, that's going to help us distinguish whether or not these atoms have charges. So how do we know what the ion will have? Well, we need to look at Bohr diagrams to help us figure that out, or our periodic table. So most atoms will form ions to complete their outer orbit, so their energy level. Okay? The outer orbit electrons are called valence electrons, and we'll see this again when we do bonding and such, but what we need to know is that in the outer energy shell, the electrons that exist in those outer energy rings are valence electrons, okay? And every single element has the same goal in mind. They want to be stable. They want to be like the noble gases. So remember our noble gases that exist in group 18? They have a full outer energy shell. They have those 8 electrons in the outer energy shell. They are full, they are stable, they are happy, right? So every other element wants to be like the noble gases. They want to be stable. They want to have electrons in their outer shell. So whether they lose, so donate, or gain electrons will be based on how many valence electrons they have and how easy it is for them to get to a full outermost ring. Okay? So to be stable, they need either 2 or 8 electrons, just like the noble gases. So like hydrogen would really be the only one looking for a second electron to be stable because he's only got 1 and he only has that 1 energy level. Okay? So an atom wants to have a full outer orbit, and all others are looking for pretty much 8 electrons. So hydrogen and helium want 2, and every other element is going to want 8. So they can either lose 1 or more electrons to become a cation, so donate it and become positive, or they will gain 1 or more electrons and become an anion. Okay, and now how they do this will depend on how many valence electrons are in their outer orbit. And typically, like most things in nature, it's going to take the path of least resistance, right? So if it's easier, so like let's say we have an element that has 7 valence electrons. Well, to get to 8, they only need 1. So they're going to likely take an electron because it's easier to take 1 to get to a full energy orbit rather than to give 7 of them away. It would take too much energy to do that. So it's a lot easier for them to take 1 electron versus shedding off 7. Now, on the other hand, if like you're in group 1 or group 2, so the metals in group 1 or 2, they only have 1 or 2 valence electrons. So to get to a happy, stable place, they could just donate their electron and be happy and stable and do it easier than having to gain 7 or 6 electrons. Okay? So they will do whatever's easier. So here's the general rule. If it's got 3 or less valence electrons, it will lose the valence electrons and become a cation. So it will donate its electrons and become positively charged. If it's an anion, if it has 5 or more valence electrons, so typically we're talking about the nonmetals on the right-hand side of the table, then they are more likely to gain the electrons to get their electrons to 8, because it's just easier to do that, and that makes sense. So typically, those elements, metals on the left-hand side of the table will donate, and then nonmetals on the right-hand side, they will take electrons. Okay, so again, here's just another representation of how to figure that out, just to make an educated guess. Everything in blue, so the elements in blue, will lose their valence electrons. They will donate them, okay? And when they donate them, they'll lose the negative, they will become positively charged. And then everything in red, so the non-metals on the right-hand side, those will take those electrons and gain them to form the anions. Now, please remember, our group 18 are noble gases. They are stable. They are not looking to donate or gain any electrons. Okay? So how do you know? How do we know how many electrons are going to be donated or gained? It's based on the group, okay? So the group that the element is in. And we can use a shortcut based on which group they're in. So the group determines the number of valence electrons, right? So if you're in group 1, you have 1 valence electron. If you're in group 2, you have 2. Group 3 will have 3 valence. Carbon group, it's a little tricky because it's 4, so it can go either way. then you would have 5, 6, and then 7.